Hello, discrete math fans. We're going to now talk about well-defined functions. Sometimes it happens that we try to define a function with a rule that ends up not being a function. Let's suppose somebody tried to define a function, f, which maps the real numbers to the real numbers, by specifying that for all real numbers x, f of x is the real number y such that x squared plus y squared equals 1. Well, there's two reasons that this doesn't define a function. First reason is, for just about every value of x, either there is no value of y that satisfies the given condition, or there are two different values of y that satisfies the given equation. We need to have exactly one. So, for example, when x is equal to 5, the equation 5 squared plus y squared equals 1, you can see it has no solution, so f of 5 isn't even defined. On the other hand, what about when x is equal to 0? Then we have 0 squared plus y squared equals 1. That has two solutions, y equals 1 and y equals negative 1. So it's not even possible to establish a single value for f of 0. So what we'll say is that anything that wants to be a function but doesn't satisfy the condition of a function is not well defined. Let's try another example. Let's try to define a function that maps the rationals into the integers by saying that if we have q, which is a rational number, and we write it as m over n, m and n are integers, then we'll say that f of m over n is equal to m squared times n. Is this function well defined? All right, it's not well defined. And the reason boils down to the fact that fractions have more than one representation as quotients of integers. You know, 1/3 is the same thing as 4/12. Now, if f were a function, then it shouldn't matter whether we represent the rational number as 1/3 or 4/12. And so the definition of a function would tell us that f of 1/3 should be equal to f of 4/12. However, f of 1/3, according to the rule, is 1 squared times 3, which is 3, and f of 4/12 is equal to 4 squared times 12, which is 192. So f of 1/3 is not equal to f of 4/12. So that shows that f is not well defined, and therefore it's not a function. So the actual output that we get depends on how we represent the input, and we don't want that to happen. Okay, that's all for now.